Okay, let's start back up. We are going to look at inheritance. And so rather than showing you PowerPoints and PDF files and stuff like that, I'll just show you the source code examples, which are a little bit more interesting. If you go into the Object-Oriented Programming and Objective-C folder, you'll see under course materials, we'll find source code examples. Under source code examples, we will find this one here, Programming Practice 2. So Programming Practice 1, if you're curious, is what we went over yesterday. So today we're going to do 2, and then next time we'll do 3, next time we'll do 4. Increase it. Anyway, so today we're going to do this one here. If you download this one, it's called WS Code 2. Actually, I'm going to download it fresh because I was playing around with it. I want to make sure I haven't changed anything. So if I download it, which I just did, and I'm going to unzip it, and now it says Code 2. If we have example 1, 2, and 3. And I'm going to start with number 1. It actually doesn't deal with inheritance, but I want to open it up and show you something about this. The reason why this example is in here is it's really showing you the object properties and how you can use alloc and init. And we saw this the other day with an iOS application, so I sort of wanted to show it to you again without an iOS, which is a regular old, just a command console application. The whole example is just main.m. If we just have main.m, and there's no main.h, by the way. Only your classes have a .h and a .m. Main doesn't have a .h. Nobody's asked that yet, but sometimes people do. But what we're looking at here is a classic little one where we've got, and this is heavily documented, so you can read through the comments on your own. But we have an NS string. Well, we also have an NS integer, an NS float, an NS everything, which we're making objects instead of primitive data types. These are now objects. So if I use the asterisk and I say asterisk test string, and I think I did this yesterday actually, but let me just show you again, because this one's in the example set. Test string is going to be equal to, this is the same way as we allocate other objects, where we're saying NS string alloc, which means allocate an NS string, and then initialize it with init. And then I think we saw it yesterday with initialize with text or something, or initialize with something. I think it was with text. We may have done a conversion or something like that if I remember this right. And then here we're using it actually after we've allocated it and initialized it, then we're using it sort of like a data member again. So an object like NSString is allocated and initialized like any other object, but then we're using it like a variable. We have NSString is equal to, and then we put the string here, which is kind of interesting. And then we're going to use the string, so we could just print out the string and use it just like a regular variable instead of like an object, which is actually kind of interesting. So just let you know, in fact, if you compile and run it, it should hopefully just print out. It's kind of like hello world. Yeah, it prints out, here's a test string in test string. It's a test string object that holds a string inside of it, and then you can perform other operations on the object. You get the same concept in Java, but you have two different variables in Java. You actually have an integer as an example with a capital I-N-T-E-G, I can't spell it, I-N-T-E-G-E-R, integer, and then you have int. They're both calling integer. Integer is an object, and int is a data type. In Objective-C, they're both the same thing, but they can be one or the other. They can be an object, or they can be a data type. So you can use them both ways, which is what this example is showing you. And they're both called the same thing. They're both called NS strings. So if you do string, you're going to have an issue here. And if you highlight your mouse over, actually click on here, you're going to see that it has to be NS string. So unknown name NS string didn't. Do you mean NS string? I can go, yeah, I mean NS string. So I'm going to go, okay, yeah. And then it's going to still complain. It's going to say, well, your interface needs an asterisk. You go, okay, put an asterisk on there. And then if I say, okay, well, then let's use it, because this complaint here is going to be that I have initialized it, but I haven't used it. It's an unused test. I'm going to go, okay, well, then let's just have it equal something like that. So I can go test is equal to at some string test. And then we put this semicolon at the end, and we go, okay, well, let's print that out then. So we go nslog, oops, nslog, there we go, just press return, there we go. And, oh, here, we'll just cut and paste so I don't have to type. Copy. Hate typing. Let's see. Paste. Looks pretty good. But let's change this one and we'll put test in here. And I should put here no alloc, no int, and we run it. And it says build successfully. And I come up here and I say, it says a no alloc, no int test. And over here it says, here's a string, test string inside of test string. I'm looking at here going, well, I didn't do an alloc and I didn't do an int. This is the part I left out because I didn't use it as an object. I used it as a variable. Most confusing thing of all. Treat it like an object, treat it like a variable. Works both ways. You just saw it. So this one here, if you missed it, isn't doing an alloc or an init, and I'm doing the same thing with it, and it's working just fine.
So does NSString have an initializer where you can initialize it one statement?
You can. Yeah, it has an initializer, so you can add the string to the string while you initialize and you allocate it. If you do it that way, you have more object behavior associated with it. It's still an object. This is just, you know, we didn't allocate it. We didn't allocate any space for it. We didn't initialize it. We just used it like a variable. That's what we did. So you can use it like, and that is what I call using it like a variable. We just added some value to it. We can also do the same thing with NS integer as an example. So I go NS integer, and then I'm going to go I, and then I can say, well, I know I is not being used, and I can go integer A, and then I can say, well, I is equal to 10, and A is equal to 20, and use it. One's an object. This is an object, actually. It could be an object, but I'm not using it as an object. I'm using it like an integer. So I'm using it like a primitive built-in data type. But it really is an object. So in Java, well, actually it's the same behavior. It's just like we have NS for all the objects. I guess it is the same parallel, I guess, with Java. Now that I think about it. Because in Java we have integer and we have ints. But string, we don't have string. We just have NS string. But we have int. But we don't have integer. We just have NS integer. So anyway. Just thought I'd show that to you. We don't have to do this, but we can allocate and initialize it like an object and use it like an object if we want to. And put the string, and we're basically, this is the same line of code as up here, this one here, but we just, I didn't allocate and initialize it, so. Anyway, yes?
So here, NS string, is it immutable or mutable?
It is. So I can say down here as an example, this one here I got, maybe I can down here I can say, well, let's just change it and say that the test is now equal to another string, and then see it out. See it. Oops. See it out. I can't believe I said see out. Print it out to the screen again. And so we have test is test. It should print out test. And then this one should print out another string. We do that. Let's see. We say that it is mutable. So we have another string. And we have test. So it does change. It's mutable. We have an immutable, immutable, and I'm going to get into that actually. And different data types that are changeable and not changeable. That I'm going to cover in a different lecture as soon as I get past the main stuff. That's a little bit too much for right now, for what I want to accomplish. We'll see that in the second weekend, so we'll see that next time I see you. But yes, it can change. It's not an object that's going to hold a value, or you have to run a method to change it. And you don't have to initialize it, you don't have to allocate it. It's just going to use the free memory pool that's out there.
In Java, it's immutable, right? It makes a copy.
I think you have both in Java.
Yeah.
You have both, just like the
Strings can be changed.
yeah.
You
Strings
can change, but on the layer downstairs, it has string internal, so it just makes a copy. That's why you have the concept of string builder and string buffer.
Yeah, you're correct in that. So the concept is slightly different. This is more of the C++ interpretation of string, where the string object in C++ works the same way as this does. In Java, you're right, though. It does. You have to actually do a little bit more buffer to it. You don't have to. Actually, Java's nice because it has the string buffers, and it has like a formatted buffer, unformatted one. It's got tokenizer. It's got a bunch of classes and a bunch of support for string manipulation and built-in methods and functionality on the string object. More so than Objective-C or C++. This is more the C++ breed. In C++, if you made a string pointer, you got to use it like a string pointer, though. You got to use it like an object. You can't do it interchangeably. You get in trouble if you do that in C++. So it's kind of a hybrid, I guess, between both languages. It's Java-like in that you can use it like an object or you can use it like a primitive. But it's C++-like in terms of the, well, it's not C++-like in terms of the pointer usage. So.
Can it be implemented as an object and non-object in the same scope?
Yeah. Once you make it an object, you allocate it, you initialize it, it turns into an object. If you don't allocate, you don't initialize it, it's a reference to an object type, and it gets used as a reference type.
If we do the allocation first and then use it as a non-object, then
It doesn't matter. That's what's going on in this example. In this example, let me take this part out of it. Actually, up here we made the string. We allocated the string here. We used it just like that other string that I didn't allocate or initialize. I just assigned a value to it. I didn't use a method on it. I just assigned a property value to it and told it to be equal to this, and then I used it to print it out. Not like an object, but like a string value, substituting this in for the string. Because this is the directive that's telling me that I need a string.
Okay.
So
Actually,
it's using it. This
when
is unnecessary. In fact, if I take it out, it works just fine.
When you change the value of the string,
Yeah.
another reference will be created with the same name.
So
That
change
will
the
be-
value here, you mean?
Yeah.
Underneath it? Sure.
No.
Oh.
What I'm saying is, like you initially initiated the test string with some value, and if you change it again, that will be another reference actually, and another string object will be created. It's not the same reference that's being used.
You mean like this? And then if I print again out, it's going to print out the same. It's the same one.
So that test string and this test string are different.
You think?
And if you print the memory location.
Ah,
Yeah.
yes.
Both
If
are
you print the
different
memory location, yes.
Both are different.
They're both different.
They're pointing to different.
But if I used it by the name, test string, this one's going to give me the second, not the first. It's going to say again.
Yeah. But now the test string has been shifted to a different location actually.
Yeah.
The first one
And
is
the
kind of
reference to it
dangling-
has changed.
The first one is a dangling pointer.
No,
Because
a memory-
It doesn't have any reference now to that memory
It's-
location.
it's a memory leak.
That's what- It doesn't have any pointer.
It was allocated, and then we allocate. It's actually not a dangling pointer. It's a memory leak because we allocated the string. We put it out here. And we put a pointer to it. We call it test string. And then we allocated another one. And we moved the test string over.
Yeah.
So now we have a piece of memory that's occupying the string, but there's no pointer to
There's
it.
no reference to it.
So it's called a memory leak.
Yeah.
However, we have garbage collection in Objective-C. We don't
And
care
so
about it.
strings
It's
are
cleaned up.
immutable only.
So it's immutable, and we do have string interns.
I'm sorry.
As you
We
said,
do have string interns for now. String intern,
String
intern, INTERN.
integer.
No, intern.
intern.
There's a pool of string, so you keep the copy of string or distinct string.
Yes.
This is string intern, string pool.
I don't know what you mean by intern.
That's a
Internal.
keyword actually in Java. Probably that has a different.
Yeah. It doesn't really apply towards the Objective-C, but in theory, it's working the same way. In practice, because of automatic garbage collection, well, actually, the same thing would happen in Java eventually. In theory, in practice, yes, it's identical. Behind the scenes, what it's doing, we're just creating garbage, but the garbage is being collected for us. So it's not immutable. We're not actually changing it. We're allocating a new one and a new one and a new one and a new one. We're not changing the old one. We're just creating a new one. But we're not worrying about the old one because the old one's going to go away. It's not going to cause any problem. If we did it enough, we could run out of memory. But we're not using it. We're not
why
accessing
would
it.
we use this?
Why would we use it?
Yeah, it's not having a practical implementation.
It isn't. I mean, if we wanted to store a string of something, and then why would we do this? I never do this. Actually, I never allocate it, never initialize it. I just create the NS string, assign it a value, and just use it. You don't necessarily have to do it this way. You don't have to allocate and use it. This guarantees it. So you create a string, your pointer points to it, method initializes it, everything's done. It's more of an object. If you're running methods on the object to parse the string, convert the string, it might make the conversion to other formats easier in terms of what kind of methods you can call on that object, because you're looking with a string object versus a reference to an object. So, in fact, in theory, you could create references to objects that exist that create memory leaks once you move the reference to another object.
To avoid that situation only, Java introduces this in turn.
Ah, okay.
Like,
Yeah.
if you initiate the string with s1 equal to some string, and s2 is equal to s1 dot intern, then it will look into the string pool and it will point to the existing value. And it will point the new variable also to the same location from the string pool.
Makes sense. Yeah.
Probably there is no such functionality in objects.
Not that I'm aware of. No. There doesn't really need to be, though. Why would we need that in Java, though, either? Unless you wanted to preserve the memory, or reserve it of some sort, or string pools.
In string
Giving
builder
a
will do
public
the
access
same
to
thing.
it.
String builder.
String builder is doing the same thing.
It refers
Well-
to the same thing, like string builder. It's mutable.
I think the functionality might be
I was
extremely
talking
similar.
about the intern use of intern key.
The behind the scenes, what's going on with the memory and how the memory is being reused or made into garbage or dangling pointers is possibly different between the two. But overall, I think the functionality is pretty comparable. So, I don't know, you could probably Google it, actually. You'd probably find everything you ever wanted to know about it.
That's what it
And at the end of the day, ask yourself, what am I going to do with it? It's a string. No, you can use it as an object, or you can use it as a reference to a string that's loaded up into memory that you're going to use. So it has a flexibility of being both, actually. So anyway, not to belabor the point. So let's move on to example number 2. Example number 2. Let me get rid of some of this real estate. Is the difference between the setters and the getters, or accessors and modifiers, and property and synthesize. This is not an iOS. This is a regular old command line prompt application. If I run it, I see all it does is build. Let me move this over. There we go. It makes a car that's a Honda Civic with a VIN 123. That's what it does. So let's take a look to see what we're looking at. We have simplecar.h that goes along with simplecar.m. And we have simplecar2. Where's my simplecar.m? Here's my simplecar.m. And we have simplecar2 that goes along with simplecar2 of .h and .m variety. It's the same car done twice using 2 different methods to show you both ways, using property and synthesize and then using setters and getters. No property synthesize. So let's take a look at simplecar.h. Simplecar.h isn't using foundation h. It's an older project type, and it's using coca/coca.h. Same thing, same library, different hierarchy, same library set. So this is just older. The current one is foundation. So why they kept the old one in there? Because people like me have old examples, and we want it to work. So. Yeah, I just ran it a few minutes ago. You know, it works. It does the same things we've been doing so far. I can exchange it with Foundation. It works just fine. All right. We got interface, and this is just a little refresher on the concept. Our data, this is our class interface, our simple car interface. It's coming from NS object, and we have 1, 2, 3. We have a string, and a number. And we're going to use some strings and numbers in here. And we have the set methods, the set VIN, set make, set model, and then we have our convenience method here, which is going to be set make with a string, new make, which is what we're going to call our make, and then end model. So this is what they call a convenience method. And I'm wondering, well, where in the world does this come from? Well, remember in the beginning we had initializers, and then other languages came out with this concept called the constructor. And then Objective-C didn't come out with a constructor. So we have convenience methods. So the convenience method, we can give the same name as the class, and we're making a pseudo constructor. But we're going to end up with problems in theory and practice. So this one here is called a set make. We usually give convenience constructors or convenience methods a different name, and we run them so we can initialize the object with the data without having to set each one of them individually. So this one just does the same thing as the sets. It just does them, and there's no gets in here, there's just sets. Here's the gets actually. But long story short, this one is just running kind of like a constructor. We're going to set the make and the model all in one rather than having to do it individually. They call them convenience methods. So sometimes people create convenience methods. You allocate and you initialize the objects inside of the convenience method, then you assign the data to it. And what does it sound like? It sounds like a constructor. So in concept, you can do your own constructor. You still have to initialize. And if you're going to do it, you're going to initialize inside of the constructor. What does that do? It cuts down on the repeated code that you have to do out in main. So in the class object, you're just essentially running the initialization, allocating, initializing, and setting all your variables all in one shot as a convenience, which is why it gets that word. So down here are the gets. I call them gets because I teach C++ and Java as well, and they're setters and getters. But in Objective-C, there's no get. It's just give me the make, give me the model, give me the year. So it's like, and you can call them get, make, get, model, get, year, which is interesting. And you can change the behavior of what you're getting and how you're getting it if you do it this way. So one of the pros of manually creating your setters and getters is that you have control over what they're doing, if you want the control. If I look at the .am file that goes along with simple car, I see my set vin. Release is not needed. It is not needed, actually. Ignore. Here, we'll just do this. Ignore the release. We don't need a release. This example, again, is kind of old, where we had to do garbage collection on our own. It was semi-automatic. Now it's completely automatic, so we don't have to worry about this stuff. But long story short, this one's also going to have an probably going to have a pool in there too, actually. But we've got set vin, and we have the implementation. We're going to take in an NS number from the users. This is a parameter. We're going to call it new vin. We're going to take the vin, have it equal to an NS number alloc init, which means we're going to actually assign this as an object and say that the vin is equal to new vin. And we just saw a few minutes ago, we can actually just do this if we wanted to get rid of that line and just say vin is equal to new vin. Oh, we just did that. Oops. Let's get rid of that, actually. We can just take that line out, actually. Vin is equal to new vin. It's right above it, actually, without allocating, without initializing it. So if we get down to set make, we're not going to release the make. But we're going to say make is going to be equal to NSString alloc. And then here's what someone mentioned earlier. You can initialize the string with a string. So we're going to init with string new make. And new make is the string that's being passed to the method when we run the method to set the make. Make release means if we had memory stored for make, actually, I'm going to put this stuff back only because the beginning part of it, well, it doesn't really matter. This stuff will be ignored. The vin released, make release, in the old days, if we wanted to change something, we had to release it. Going back to that, actually the good string conversation we had a few minutes ago, we didn't release it. We just left it out there. And I said it created garbage. It's an inaccessible memory location because we moved the reference to that old string. We moved it to a new location with a new string that we put in there after we created more memory, which is what we did when we had made that assignment. We're doing the same thing here because vin is pointing to something and make is pointing to something. And in the old days, without automatic garbage collection, then we'd have to release it. Release it means get rid of it. Tell the garbage collector, this is semi-automatic garbage collection. Tell the garbage collector that we're done using it. So release, say, okay, we're done with you. put a little flag on there that says pick me up, I'm done with you, destroy me. It didn't destroy it like new and delete does with C++. Instead we say retain release in Objective-C. We used to say that. We don't say that anymore. But that was the old style and how the language was originally designed. Now it's more like Java. Just get rid of it. It'll go away. Don't worry about it. Garbage collector will pick it up. Which is what we do in Java. We don't care in Java. We just create it and let it go. And create another one. Let it go. Create it. And just use memory all you want. And don't worry about it. But this was the old style way. This is what this release means. We released it to get rid of it because we're going to assign a new one to it. And we allocate, we initialize a new string, and we put a new string there. This is a different memory location, different piece of memory. That one is garbage, the old one. So we released it first. If you look at old Objective-C source code examples, you'll see release, retain all over the place. Because we had to semi-automatically control what was going on with the garbage. So that we could, it's like how we would take our garbage and put it in a can and put it out on the side of the street. If you don't put it in the can, you don't put it on the sidewalk, it doesn't get picked up. Well, that's what release is doing. Retain is keeping it in the garage. Release is putting the can out. If you don't put the can out, it's not going to be picked up, not going to be collected. Now Java just goes into our house and picks up all of our garbage for us. We don't have to release any of it. Now that would be nice if the garbage collector, the real garbage collector, could figure out how to do that. Just go through my house, pick up all the garbage, take it all away. I'm not going to collect it for you.
This release is happening at the object level, right?
Yeah.
Not the overall.
No, it's not actually happening at any level. It's happening with the runtime environment that's controlling the allocation of the memory. Everything's dynamically allocated, and the runtime of the system is controlling the memory management. And release says, go ahead and pick, I'm done with this. The garbage collector component of the runtime is going to come by and pick it up, throw it away, reuse it, reuse that memory address. So you're not really doing it with you're not telling the object anything. It's outside of the object's control because the object left it. You're just telling the garbage collector who's going to sweep around occasionally that, hey, they can pick you up. You're done. It's kind of like, what influence does the garbage truck have in your daily life? None. Well, hopefully none. It just comes around once a week and picks up your garbage, or twice a week, or however your service is set. Well, this is just a service that runs on the computer. Actually, OS runs constantly. There's a garbage collector that runs, which is kind of different between Windows. There's no garbage collector. So, I shouldn't say that. I think there is a garbage collector now in Windows 8, but I'm not sure. Don't quote me on that. But it's not part of the object. It's part of the environment that the object's running in. Okay, same thing here on the model. And then we have our convenience method. In our convenience method, we're saying here, this is the method here. It just got word wrapped onto two different lines, where we get set the make, and we have a new make and the model. It's going to be the new model. And then we're going to reuse our methods from earlier. So we're going to say self space set make and pass new make to it. So in C++, we don't have to say self. We don't have to identify ourselves. We just run the method as if it were a method call inside of the method. In Objective-C, actually it works the same way in Java, I believe, as well. In Objective-C, we have to say self run this method on you, which is syntax is slightly different. Well, this syntax in general is a lot different, but the concept is slightly different because we're running this method call and we're sending the message to ourselves rather than just saying, you know, new make. If this new make method, set make method, were inside of a C++ program, we would just go like this. We just go set make. We just type in set make or whatever, and we would just run the method. Can't do that. You have to actually tell who you're going to run this method to, and I want to run it on self. And I think Java's this, I think, actually, if I remember this right. And anyway, the get methods, just return make, return model, return bin. And people came and looked at this and went, isn't that kind of repetitive? And you go, and isn't this kind of repetitive too? We're just making the assignments, we're making the returns to get it, you know. And then in the old days we had this in here too, we had a dealloc. Because we alloc, and then dealloc was a method that ran kind of like a destructor. So C++ has a constructor, and it has a deconstructor and a copy constructor. Don't have to worry about this if you don't know C++. But the destructor had a bunch of delete this, delete this, delete this, because if the object allocated memory with new, you needed to delete it. The only way you could delete it was when the object went out of scope. And then you delete to the destructor all the memory that the object allocated. Same thing. This is a destructor, it's a dealloc, which means when the object goes out of scope, it runs dealloc. Don't have to put this in here anymore. Doesn't matter. I'm going to leave it in here, but the project will still compile and run just fine. Don't need it. It's outdated because now we have automatic garbage collection. So we don't ever have to release anything, but release is the same thing we did up here before we assigned it to another string value. So we just go min and then super dealloc, get rid of the super object that's inside of us, because all of us have object from NS object that we created because we inherited from NS object. So we got rid of object, NS object, we get rid of make model and then get rid of it all. And we just cleaned up the memory. So you don't need that anymore either. So, but I thought maybe I'd show you it too, just in case you see it out in source code, which there's a lot of, in fact, up until this last version or last two versions of Xcode, there's a lot of legacy code out there that has that in there. So this is the way I showed you yesterday, and then towards the end of yesterday I showed you this way. This way, there we go, with all these properties. Properties and synthesize. So the purpose of this, and you can read through this example on your own and read through the comments, but it solves the property and synthesize, solves the problem of having to make the setters and the getters. It replaces the accessors and the modifiers. It makes it neater and cleaner. So instead of doing set make, set model, set bin, you just property it, and then you synthesize it, creates all of the methods for you. So what do we do here? We got, and this is actually not needed anymore either. We saw this yesterday with our temperature. We didn't do temperature control. We did, yeah, we did. Fahrenheit to, yeah, we did temperature. Like, what class is this? I know it was just yesterday. No, because I do just Monday or no, actually it was Friday. I did currency conversion in another class. So it's like, wait a minute, what did I do? Anyway, long story short, by the end of the weekend, my brain's too mixed up. This is unnecessary now. In the old days, this was necessary. It's not necessary anymore. We can leave that out, actually. We didn't put that in yesterday. So when we did our temperature conversion program, we just dragged things over, and we had little buttons here that were connections with the view to the view controller. This isn't a view controller. We don't have a view. This is just an object. So we have @property, and we're going to set. And this is actually unnecessary now as well. We don't have to retain it. This makes it, this retain is now strong and weak. Weak is no retain, strong is retain. So we have strong and weak now that replace that. Weak says, if I'm done, you need the memory, go ahead and use me. I don't care anymore. I'm releasing you. Let me go. I'll let you go. It's weak. It doesn't hang around. Strong, it just retains through time. It never goes away. Never gets garbage collected. Why do you want that? You got a global variable. You got something that's not going to go away. Why have the garbage collector come by and look at it? You can just mark it strong, leave it alone. It just doesn't touch it. Just leaves it alone. Doesn't even bother looking at it, which is kind of easy. This is what retain is doing. It says, don't bother looking at me. I'm going to stick around. So with the read write means we can change the value and we can read the value. You know, it's the same thing read write means in any other context. So we take @property. And we can have a string, and a number. In the temperature thing, we had a label, a button. You know, it's the same concept. We have a make, model, and a bin. And then the convenience method, we can still have this convenience method, and this convenience method can still be run. It doesn't really matter. It has nothing to do with it. And then we have the @end to close it. And then in the .m file, we synthesize. We synthesize make, model, and bin, and then we have make and model, and this is our convenience constructor, our convenience method, and then we're inside of our method. We're just running the self new make new model. We're running the set model, and sending it the new make new model that we're getting from the parameters that are sent to it from the function call. So it's not, it's the same program, but you can see there's fewer lines of code, easier to do. So in one of the assignments, you'll have to use synthesize. And as I was mentioning, I think it's like assignment 2 or 3 or something like that. It requires you to use property and synthesize. So this example is in code sample 2, just in case you need a refresher another month from now when you start looking at this. In main, we'll take a look at main. Main has got the auto release pull. I can actually get away without it. I can take it out. I'm going to leave it in here just because I still have those retains and the releases. We have pull drain down at the bottom. In the old days, we had all this memory management we had to do. We had to create the pool, load everything into the pool, and then release the pool, drain the pool after we released any objects that were in the pool. Which is here's kind of redundant because you're going to drain the pool. Why I'm going to release the object? Does it really matter? It's kind of like, you know, taking everything out and then destroying the big container that everything was in. Just destroy the container that everything's in. You're going to destroy that at the same time. Take it all away in one shot. But it's better practice to release it in the old days. But long story short, you don't need that anymore. In fact, if I comment this out and then comment out the pool drain down here, I can even take the release out of here too. And now we're looking at what we just looked at yesterday. But this is an older example, so you're seeing that in there. So I got simple car, my car, alloc in it, that's nothing new. And got NS number, that's going to be a new VIN. And I'm going to run an NS number with initializer 1, 2, 3. Isn't that the same as NS string with text and then giving it a text? It's the same thing. So all of the NS number, NS string, NS integer, all that stuff has an initialize number with init, or initialize with text, or string with text. So it's the width. The width is going to give us the, the kind of the same format. And sometimes you have to look them up, or you just start typing it, and the autocomplete will put it in there for you. So we have my car here. We're going to set the VIN to the new VIN that we created. Or we could have just set it to 1, 2, 3 as a number, actually. And then we have set make to Honda and model to Civic. So we're using the convenience constructor here. And then we're going to print out the car. We didn't make a second car. We only made the simple car. I can make a simple car 2 out of it just by putting a number 2 here. So if I do 2, now I have simple car 2, but I have to allocate it with a simple car 2. There we go. If I allocate it with a simple car 2, then it's going to complain that I haven't used it down here. Let's see what it's going to complain with. It's going to say, unknown simple car 2, did you mean simple car? Oh, because up here I didn't put simple car 2 in here, so hold on a second. Simple car 2. There we go. Hello, come back. There we go. So actually I have the same example running, and it does work. So it's got the same thing. So now it says Honda Civic VIN 1, 2, 3. Same thing I did originally. I just changed. I put a 2 up here, 2 up on the import, and a 2 here on the car. Same program. It's just 2 different ways of writing the same object. So. All right, so that's the property and the synthesize, without showing you boring PowerPoints. So let's go on to number 3. Now number 3, I believe, is inheritance. Nope, it is not inheritance. Well, let's see what number 3 is. It's probably going to be the next example that I'm going to look at. What is significant with number 3? Number 3. Inheritance. We're doing from NS object. Ah, here's the number 3. So, in number 3, we did a C++ style initialization using private. So, we're still looking at an interface, and the interface is person : NS objects. We're not really doing any inheritance yet with this. It's the next set. It's the next block I have to download that's going to do this. But we use an instance data here to declare an @private, and I have in here NS string name and a string integer age. And then I have some methods down here that I created. This is extremely redundant and not needed, but people like to do that because they can't remember that it's private. It is private, actually. If you put it inside of the opening and closing brackets, it belongs to the interface. And so it's visible to the interface, and then it's blocked on it. By default, it's private. which is actually kind of interesting because now we're going to explicitly say it's private. Well, then we can do this if that's the case. We can make it public. You do that, then you can break the rules just like you can do in C++. So in C++, you can go public, private, protected on your data, because in inheritance you're going to use it, and let's say for the same reason why you would do that in C++, you'd do it in Objective-C. If you couldn't figure out, oh, we don't have any friends. There's no friends in Objective-C. So you can get by the public, private, protected thing with friends in C++, which is the better way of doing it, but people say don't make friends. Don't make friends with C++. The age-old joke. So, don't make friends with C++. It's actually pretty bad practice. It's a violation of the rules. So if you make friends with it, then you're violating all the rules. So, long story short, if you make a friend function, you can leave this as private. So, I don't know, friends aren't supported in other languages. If you make it public, and what I'm talking about is an inheritance. So in inheritance, if you want the inherited class to be able to touch the data directly and assign values to it without using the methods that you've designed to work with it, it's going to touch it directly, then you got to make it public or protected. Protected will make it visible inside of it. By default, it's to the public view. To the public view, it is private. To inheritance, it is protected, which is kind of moronic, actually, because if I inherited this by making this private, I can't touch it, and there's no friends, there's no way for me to manipulate it. So if I wanted to make this object very secure, I'd do this. I'm changing the default for inheritance. It didn't do any change at all to main, but for inheritance sakes, it's no longer protected. It's private, which means I can't touch it, I can't do anything with it, and I can't make friends with Objective-C. It doesn't work, so there's no way for me to violate the rules. So I can't do anything while it's protected. It's secure. I won't use that word protected because that's misleading. It's private. So anyway, long story short, I can do the same kind of things that you do with those access modifiers with Objective-C. Here is a person with an initializer. We're returning a person. It's init with name. We're going to initialize it with a name. And we have an age, access getter, and a speak, another method called speak. And over in the person.m, we have the implementation for it. And it's showing us the init with name implementation where we're going to create the super. And if you want to read it through, download the example, read through the comments on your own. But you can remove all of the releases and the retains. We don't need any of that, actually, anymore. But the example should still work. Actually, let me just make sure it does still work. It does. Hi, my name is Barbara, and my age is 500. How did I get that old? I don't know. Anyway, probably because in main I set it to 500. And now, look at that, it's unused pool. Yes, I know it's unused because we're not using you anymore. So I can get rid of the unused pool. Don't need that. And a string with string barb. Okay, good. Right. So barb release. We don't need to release you anymore either. So. And this one is using foundation, and then foundation has NS string inside of it. Foundation has NS, we don't even need this to use this anymore, but you can see foundation gives us the basic, and then we can go NS. We don't actually have to do NS string. We can get it out of foundation, which is going to give us everything. So long story short, we're also using imports. Oh, this is the other thing I'm glad I looked at this. So remember stdio, we can include it or we can import it, doesn't matter. Let's decide to import it. Well, I like using printf down here. So printf, and I'm printing out the string. I'm taking the string and I'm converting it to UTF-8, which is just a string format for the command console window. So we can change the text formatting, actually, of this string. If we wanted to take it and put it into an extended one to support special characters and things. So this is kind of a hodgepodge kind of example with a bunch of weird stuff in it. Weird, non-standard stuff that we don't see, but we can see. We can bring in C++ concepts, and we can make it just as bad as C++. All right, so the inheritance I really wanted is not in code 2. It's going to be in code 3. So let's take a look at code 3. I wanted to get us into inheritance. So let's see. Source code examples down to programming practice number 3, code 3. This isn't it. And we're not bound to have, oops, it's up here. Code 3, yes, this is the one. Inheritance 1, inheritance 2, and protocols. So we'll get to see some new concepts here. Inheritance number 1. Inheritance number 1 looks like this one. What do we got? We got in a person. So remember person from yesterday. And person from yesterday, this example is extremely nice because it's very straightforward, no tricks. Not like the last one I showed you that has a hybrid C++ programming technique in it. This is 100% Objective-C. So instead of using property and synthesize, I just put integer age in here. And I've got a property here. That's very uncommon. You're going to see one or the other. It's either you're going to use property and synthesize, or you're going to use data this way. I kind of mixed and matched it. But I did this because this was the old style way of doing it. Because this isn't an object, it's a data member. That's an object. This is the NS part of it. So a lot of people have this theory, you put the objects in the property and synthesize, you put the data there. Little stuff like this, a counter, and age doesn't really belong here. I should have put age in here. But in theory, there's no harm or foul to doing it this way. But it's kind of abnormal to see it done. It's unusual to see both of them being used. Someone will do it this way or someone will that way. Or if there's a reason of doing it this way, I like to put the primitive data types in here. I don't know, because I don't think of them as objects and I can separate them out. Why? It doesn't really matter. So. Alright, so here I've got this set age and this get age instead of calling it age, which is the property synthesize way of doing it. So this one's doing both. It's showing us the property synthesize and it's also showing us the inheritance part. Alright, so set age is going to say that age is going to be equal to x, and x is coming in from the command line. And we're going to print out, and yeah, this is kind of bad too. I'm using a printf in here. We're going to print out, instead of using an NS log, the age is this. And then the get age just returns the age. It returns the age. So if I look at main, I should be creating an age in here. Let's see. I got person. I got object 1, which is a person, and I'm allocating it, initializing it. And then I have employee, this is person. And he's object 1, and object 1 I'm going to set the age to 10. And then object 2 I'm going to grow some. So let's take a look at object number 2 here, which is going to be employee. So person is coming from NS object. Employee is coming from person. We can put a space in here actually if you want to. It should have been a space in there. It doesn't really matter, I'll compile both ways. But I have the colon person. It says I'm coming from, I'm an employee, and now instead of it being NS object over here, it says person. So which means I'm inheriting from person, and I'm including person.h in here. Same thing you do in C++ actually. And now I've done the same thing. I've got an integer ID over here, and I've got an at property NS string job title. It's going to be the name of the property. And then set ID. I don't have a get ID, do I? It doesn't really matter. I don't even have a get. Don't need a get for the job title. And then I have grow sum. So I'm going to age the employee. So if I look at the .m implementation of this, in the implementation I'm using employee.h and person.h because every employee is a person. And in my implementation of employee, I'm synthesizing job title because I propertied it on the others file. Excuse me, in the interface. And then I have an initialization, which is going to be my plain init. My plain init is going to run self super init. You can actually leave it out. You don't even have to put the init in there. Init works anyway. If you don't overload it, this is overloading it actually. If you don't overload it, it just takes the base class init from NS object to initialize it. Which, in essence, this is unnecessary. But if you didn't put this in here, a lot of people would think, oh, you don't know what an initializer is. So what ends up happening is you end up starting to work for a company, and the company says, oh, we have these standards. Everything must have an initializer. Everything's got to have this. Only use property and synthesize. Only do this, only do that. And then you get into a practice of doing something a certain way. And this is pretty common, actually, as a requirement. Initialize it anyway. It's like, why? It seems redundant to me. I never really quite figured out why. But, okay. Property and synthesize, I kind of agree with that one. Do property and synthesize for everything. Makes it cleaner. And then you have nothing. If you don't actually have anything up here, let me go back to here. If I don't have integer age in here, I don't even have the opening and closing brackets. I don't have anything. This looks cleaner to me. And then I put property. I have to put it back because I have. I'm actually initializing it, but this opening and closing bracket that's got this in here looks sloppy. It's very C++-ish. But it was the old way of doing it in Objective-C. So I can just pull out the opening and closing brackets. Sometimes I see the code with the opening and closing brackets because it gets put in there by default. I also see it when I start creating, we'll create a new object from scratch in a few minutes, and you see gets put into the interface, gets put into the implementation file as well, which is what we saw yesterday, because it could go there. This interface is public. If I put an interface inside of the implementation file, which I can do, I can come up here and go at interface. Well, I'm not going to do it here because I'm going to mess up my code, but if I put it in here like we saw it yesterday, it's private. It's only visible to the implementation. It's not visible to the public. So only the implementation file can see it. The public can't see it. Wait, why do you want that? Because you're going to do that because you're going to put a method in here that's only used in the implementation. Because one of your methods is going to call another method that's going to do something, but you don't want the public calling that method. You just want the implementation calling that method. And that method is usually doing some sort of a conversion, or it's doing, I don't know, something, I don't know, it's doing something that you probably could have put into the other method bodies, but you'd be redundant. You'd be like repeating the code all over again. It's like making a function in C. So you only call the function, you just call it. So that's where you would use inside of the implementation, you'd put a separate interface that had that function in there. In fact, you'd put the whole implementation into that function, if that were the case. Which is kind of, well, you put the prototype in the implementation, you put the prototype in the interface, you'd put the implementation inside of the implementation part, just a couple lines below it, and it's not visible outside of that file, not outside of that implementation. But anyway, long story short, you could have very easily had just stuck it in the other implementation. So, employee, as we were looking at here, hopefully I didn't, it comes from person, and we have implementation. We're going to synthesize the job title, we're going to put our initializer in here, we have the set ID, and we have the grow sum, and grow sum is getting the age, and the get age is coming from person, because every employee is a person, and person has the get age in it. So we didn't have to redefine, we just reused this method. So what I want to do is kind of create another inherited class. I'm going to inherit something from employee. I'm going to put supervisor in here. So I'm going to show you how to do this because I haven't done this yet with you. So to add another class to a project. So let's just say I created this blank project template. And I have this project out, which is, it's populated already with a few items, but it's pretty much the standard template, actually. And these classes were added to it. So I'm going to go up to File, and I'm going to say New, and then I'm going to say File, because I want to add a new file to this project. And then I get this little GUI that comes up. And the little GUI says Objective-C class, which happens to be what I want. We also have a couple of other items I'm going to talk about, probably not till the next weekend. One of them is the protocol, the other one's the category. Where a protocol is an interface. Very similar to, actually, a category is sort of like an interface as well. But both ways of interfacing extra behavior, extra functions, extra stuff. Not in the hierarchy, but it's used for the same purpose. It's like Java, when you extend a class and you implement this interface and this interface and this interface. We're extending one class from another class in Objective-C. We're not using extend, we're using a colon instead. And then we're including this protocol, and that protocol, and that protocol, and that protocol, and this category on all this other stuff. It supplements the class with more behavior. It tags it as part of a member, as a hierarchy. So we can create multiple inheritance through the protocols and the categories, actually. Categories, you're going to put external behavior in there. You're going to put class level stuff in there. Methods that you want the class to have access to, but it's not defined inside of the class. Protocol, think of it sort of like rules. Isn't an interface a bunch of rules that you put in Java? So if I created a Java class and I extended another class and I implemented an interface, and the interface that I implemented was called print, or toString or something. You don't have to because it's already given to you in Java, but in theory, there would be a method or two inside of that interface, which is just method prototypes. And if I didn't implement that functionality inside of my class that implemented that interface, I get an error message. It won't let me compile it, won't let me do it. It's like a rule. A protocol is another word for rule anyway. It's a rule that says I have to have this method. We do the same thing in Objective-C. So we use the protocol, and I'll show you the syntax for it. I'm not going to do it right now, I'm going to inherit another class. But eventually what we're going to do the next weekend is start using protocols and categories. This weekend we're just going to go through inheritance. But the next time I see you, because we have 2 full more days of instruction on this, we're going to use protocols, categories, and show you multiple ways of combinations of using these together. But essentially what we're doing is the same thing we do in Java. We're just using different syntax for it and different wording, but it's an interface. But long story short, I want to create a class, so I'm going to click on Objective-C class, and I'm going to click on Next. If I do that, I have subclass that shows up underneath, and it says NSObject. But I want to make a staff. No, what did I say? Supervisor, and the supervisor is going to be an employee. So I'm going to click on the little arrow, and I'm actually going to automate things for me. I just type in E. It brings up employee, actually, instead of scrolling through the whole thing. I want employee, and this one's going to be called supervisor. Supervisor. And then, because I don't have a GUI, I'm not going to get any of these options down here, and I'm surprised that these options actually exist, because they took away the XIBs. Maybe they didn't take them away completely, because I haven't created too many projects with this yet, but now everything's storyboard. The XIB is the little window. It's the interface. Well, it's the interface builder, but it's the view that you're looking at. In the old days, it allowed you to click on here for iOS. This is probably a bug because I'm not in iOS. Why would I want to target this for iPad when I'm in a Mac 64-bit console template? That's a bug. So that shouldn't be on the screen. Anyway, unless I'm in the wrong, let's see, make sure I am. I'm in the wrong category. That's not a bug. It's user error. It's me error. I need to click down here under Coca. Because it was actually clicked up here under Coca Touch. Common mistake, by the way. And until I looked at that, if I hadn't focused on that, I probably would have went ahead and created it. It would have given me probably the same class template. But some of the inheritance stuff may have been weird or something. We can try it out, see what happens. But what I really want to do is I want to click down here under Coca, which is actually kind of weird because even if I were in iOS, I don't have XIB files anymore. And anyway, if I click on Coca down here, I can click on C++ and put in a C++ class if I want to. I don't want to. Or a user interface. So I could put a view in here, which is actually kind of interesting. Now let's just do here. This is the one I really want.
Those templates are not showing up here.
I'm sorry?
Cocoa template. Those are templates.
What do you mean? Oh, go back. Before I was under Coca Touch. I'm not in an
I
iOS.
was not able to see the Cocoa template.
Really? I'm on the iOS 7, the newer release. Are you on that one too? The brand new Xcode that came out?
I downloaded it yesterday.
Are you in the same example, Inheritance 1? Or are you in a different project? Inheritance 1 is an old project type.
Okay. I'm trying to open a new project.
Okay. Actually, I'll do the same. I'm actually now kind of curious. Maybe they blocked it. So I'm going to do OSX application console, which was the same project type I was in before, but I was in an older version of this project type. And I'm going to call this one test console. Core foundation looks pretty good to me. Either one or foundation works, one or the other. I think I was on foundation before. Now I'm going to click on it. So now I'm in here. Oops, I don't want core foundation. That's C. Hold on. Hold on a second. Let me pick the right project type first. I went foundation. There we go. Testing again. I know, it doesn't really matter. I'm going to throw it away in a few minutes. Now I got the .m. I got the right project type. Core Foundation is going to give us C program, C++ compatible. We don't want that. We want Objective-C. So anyway, if I come up here, click on File, New, File, I get the same thing as I got before. Oh, you say when you click on here, next. Yes, I got the same results, actually. Actually, I got employee, and employee is not even part of my project here, which is actually kind of bad. This should go to, if I'm in, this should be NS objects. Anyway. Let's just add a class to this one. So, file new, I'll add a no one to the other one. So if I go file, new file, if I go into, I click on the OSX part on Coca, click on class object, click next. I want to do NS object. I still don't have an XIB file. I have a command prompt. I'm saying there's something weird about these menus. Anyway, so this one's going to be called person. And I go next. And I put it in the same project. Then I get the two. I get the person.h and I get the person.m. And you can do the same thing, and you can get employee. And you can do the same thing again. If I come back here to this example, where I was before, I had person.h filled in, person.m filled in. And then we have employee that comes from person. So let's make a supervisor here. So file. And then when I come back in here, this is going to be chosen by default, which is the part I never liked about Xcode. It's like, which is how I got into trouble to begin with this, because it was already selected up here because that's the last one I did. And I'm thinking, well, okay. Anyway, Objective-C class under the Coca interface. Click on next. Now this one's going to be called supervisor. And I want to inherit from employee. And I don't know about this XIB file because I'm in a command console application. So it's not selectable, but why is it even showing up on the screen? I don't know. Let's click on next. Click on next again. So now, if I look at in supervisor, I see I already have the import for employees. So it's pretty automated. And then I have supervisor employee coming from employee. So if I look at employee, I get the same thing coming from person. So if I wanted to, actually, let's just take a look here. Just cut and paste here. We'll give this guy another. So we'll give employee dot. Ooh, we'll give supervisor. We'll give him a property. And so let me job title is employee. Let's just call it employee ID. So now he's got a string employee ID. And then over in the supervisor.m, I'm going to synthesize it. There we go. See, I don't have to type very much if I just follow the screen. And now down in main, I can make a, let's just put it underneath all this other stuff. I can make a new instance of supervisor and say supervisor, supervisor, and then I'm going to run into another problem I don't like about this interface. It doesn't know about it until I save it, and I haven't saved it yet. So it doesn't know that I've added a supervisor, so it's not going to show up in any of the pull-down menus. So if I save the project, it's going to go, oh, now we have a supervisor. So now if I type in super, still not doing it. Oh well, supervisor. Oh, here's the other problem too. Import supervisor. That might help. Okay. So supervisor, and what supervisor we're going to do here? My soup is going to be equal to a supervisor alloc init. And you're going to say, whoops, let's see. No visible interface for supervisor declares init. Well, because I misspelled it. I-N-I-T. There we go. Initializer. And then I can do something with my soup. I can say, well, let's just set the age of my soup. So my soup set the age to 50. I'm going to put 50 here. And then here, we'll just grow my soup. Because my supervisor is coming from employee, which is coming from person, I get everything from the hierarchy below. And what I wanted to show you was this line here. I went through the employee, and we didn't have an initializer? I didn't do the initializer in employee, did I? I put all this INIT stuff in here. We'll see. We can make a supervisor. I didn't put the initializer in here, but I'm going to get one. I'm going to get one from super object. So I didn't put the code in there, and it's going to come back and it's going to say, oh, you have to put it in there. No, it's not going to do that at all. Instead, it's going to tell me that the age is 50 and that the growing results are 500. Okay.
When we write in Java, can we write employee comma per person?
We're in main, and
When
what do you want to do?
Employee comma person.
No. If you're up here, you're seeing supervisor.
Yeah.
You wouldn't want to do that anyway, because a person's already inside of employee. But if you do this, it's just NS object's a different object actually. You're going to see this thing, and it's going to say expected identifier with an opening bracket. Well, you put the protocols on here and the categories on here, but it's just like Java. You can't string them. In Java, you can't string them either. You can string the interfaces. You can't string the inheritance. It's just like Java in terms of a single line inheritance. This class extends this class. In C++, you can go comma, this one, comma, that one, comma, that one. C++ supports the multiple class inheritance, but there's no interface. Instead of having a separate, well, Java says a separate interface. Objective-C has a category and a protocol, which kind of like the interface. I'll go to that later. And C++ doesn't have anything. Everything's a class. So you have to have, this class, comma, that class, comma, that class, which is weak because it leaves itself open for inconsistencies. You can inherit a dog, a horse, and a train inside of a boat class. And be like, well, what matter? Why are you doing all that? So this is one-to-one, one line to one line. One class is going to inherit from another class. But we can use protocols. If we do that, the syntax is slightly different. Actually, I'll show it to you. I believe it's in the same protocol. Let's look at a protocol. We're really going to talk about this more next time, but I want to show it to you because then it'll make the bigger picture look, which is why it's in this example set. Let me get rid of the real estate here, make it a little bit easier. All right, so we have a complex.h, which is a class for representing a complex number. And we have a protocol called printing. And so complex is inherited from NS object, but we don't have a comma printing like we would have in C++ to inherit from multiple objects. Instead, we're not inheriting. We're using an opening and a closing bracket to say we're going to use this printing protocol. The printing protocol is right here, and it's just a .h file. There's no .h and no .m that goes with that. It's not an object. It's an interface. Why they didn't call it an interface? Why did they call it a protocol? I don't know. Substitute the word protocol and put interface in there. if you go back and look at this part here, isn't this class complex extends NS object implements printing if you're in Java. So, and if you're in C++, it's a comma printing, comma this, comma that, comma everything else in a multiple inheritance from, because everything's a class in C++. So here we're really implementing the protocol printing. What does printing have? And if I look at printing, I see the template that was put together here where it says at protocol. Well, Java is not at interface, or not at interface, interface space printing. We got the at in Objective-C. And then we have the interface printing. So we have the at protocol to give us the rule, and at protocol has got print in it. It has a method called print in it. And the interface implementation of it is nothing more than a file that's going to say, in fact, this is redundant. We don't need this actually in here. But it's not really adding any functionality to it. But if we wanted to put methods in there, it would say, this is the protocol that you must implement. So interfaces are called protocols. So the interface is, not to be confused with the interface in this file, defines a single method print. And it's going to need that you implement this protocol in two different ways, one with a fraction and one with a complex number. There's two different ways of doing this. I'm not prepared to go into this much detail this term because I don't have all this. I haven't introduced other concepts too that I need to introduce first before I get into protocols. But long story short, we have some methods that are required and some that are optional. So we can mix and match with what we want the rules to be. We define the protocol method print if in complex.h we're going to implement printing as a protocol, or as an AKA interface, then we must have a print method in there. We don't have to put the print method in the .h file. Don't need it. It's in the protocol. So the .c++, aka .m, in this case, has got the print method in it. Here's the print method in here, down here. If I leave this print method out, I end up with an error message. If I take this out, I should get, well, let's see. Lo and behold, it's going to signal out on me. It did. It failed out because I didn't implement it, and my interface is going to stop at this printable sign here. It says print. It's going to say, oh, this throw exception is because the method doesn't exist. I dynamically tried to run it, but it can't run it because I just took it out and I deleted it a few minutes ago. So if I stop the execution, go back to the code where I was at. Where was I? I was in the .m. Oops, I can't undelete it. Well, I could put it back in a few minutes. Actually, I'll just take the one out of fraction. I take this one out here. Oh, it's a different implementation. Bummer. There's no undo. Let's see. I could just reset here. We fixed that problem. Put it back. Okay. Okay. That's why I love zip files. Fix the problem. Go back in here. Put it back in here without having to retype anything ever again. I have the printf. I got the real and the imaginary. So the complex number here, if I print out a complex number, I have this implementation. Over here in the fraction, I have a definition of a fraction. This implements the printing protocol. Got printing up here, just like as if it were a class actually, but instead of putting it here, I've got it next to it. We can do this. Testing. I don't know, testing again. We can implement as many interfaces as we want, just like Java. Java extends one class, implements as many interfaces as you want. Objective-C extends one class, implements as many protocols as you want. Same concept. We only have one in this example. So here we have numerical, we have and this could have been, property synthesizer could have been done the other way too. Numerator, denominator for a fraction. And then we have an initializer here in it with numerator and denominator. So if I come over here to the .m file, I can synthesize numerator and denominator. This is old-fashioned as well. In earlier versions of Xcode, we renamed when we synthesized to refer to the synthesized version. Scratch it from your memory. You don't need that anymore. I don't know why they put that in there, seriously. I don't even, I never liked this to begin with. Why do we want to do it? Just give it the same name. If you give it the same name, then you don't have to refer to it. In fact, you could refer to it with the underscore or without the underscore. But this is back when Xcode used to do it for you, which I don't understand why they took that out. In the earlier versions of Xcode, when they first put property in, if you added property to the .h, it automatically synthesized it for you. And you looked over into .m, and all of a sudden, hey, look at that, synthesized. Fantastic, and it synthesized it this way. And then you refer to it with the underscore when you looked at the property of the variable. Why? Anyway, this isn't used anymore, so I left it in here. Because you'll see old examples. And the problem is when you start looking at examples for Xcode and Objective-C, you'll see you'll see this, you'll see the non-synthesized stuff, you'll see the regular stuff, you'll see objects that are completely allocated and initialized all the time, and then ones that aren't. Lots of inconsistencies throughout the years. Anyway, long story short, this one is creating a new fraction, and it's returning a fraction. And it returns self as a fraction. So the protocol's in a separate. It doesn't have any implementation. Think of it like an interface. It just has the rules in there. And I'm going to go over protocols and all the options you can do with them next weekend. So look at the main. So if I look at main, I've got an interesting main actually. So we have fraction, and fraction here is a fraction. It's allocated, and then it's initialized with 3 and 10. And then I have a complex number, and I've got it allocated, and then I've got it initialized with a real and an imaginary number. So 5 and 15. And then now I have a printable interface, protocol object with an ID which is generic. But it's a printable. So I made a implementation of the required element in each one of the 2 objects that implemented this interface. But now I'm using it like a protocol object. So first you define the objects, and then you define them inside of the interface, and then this ID tells me I can make a generic object of this protocol type. So it brings all of our objects together. Just the same way as I think they call it tagging in Java. You have an is-a relationship when you include an interface. You tag the object. The object becomes part of the same family tree. That's what this is doing. If you do an ID on a printable, anything that implements the printable is part of the same family tree. So they're both, even though they're 2 separate objects that have absolutely nothing in common with each other, they both implement the same protocol. And so they're both of the same data type as printing, which is the protocol. So I can create a generic ID, call it printable, give it the printing protocol data type, object type, and then down here refer to it with ID. So printable, so my data type is ID, which is generic. My variable, my reference variable is called printable. It's a printing protocol. It's a protocol object. So because I've casted it using the protocol. I'll get into more examples of this, and we'll build one the next weekend. But because people wanted to see it, we have. I'll go back to inheritance in a few minutes. Printable fraction. A fraction is printable print, and now we're saying printable complex equals complex. They can be equal. We can assign one object reference of another object reference as long as it's within the same hierarchy or family. Printable's the protocol, the ID's are printable, so as long as complex numbers are printable, it is. Fractions are printable, it is. It can all could be equal to printable.
Forward slash n, is that a break? Forward slash print and forward slash.
So yeah, it's just printing a line return.
Just a break.
This is a C++ or C actually, IOstream. No, I mean stdio, printf.
Just to print a blank line.
Yeah. Just prints a blank line. Could put the forward slash n over here. I did this with it if you wanted to. Doesn't really matter. Just put it down here. Printable, print, printable, print. One's a fraction, the other one's a complex number. I'm referencing it through the same protocol object. And the protocol object, that's the key right there. So I'm making like objects out of it, but I'm running the same method. I'm running print on it. So I can stick a bunch of methods inside of that protocol, attach it to a bunch of different objects, and then I have some pretty decent functionality that would work on everything. So if I had a bunch of objects that had like relationship with each other, like, I don't know, it's kind of like how Java's object has toString, and then you overload toString in every one of the, but they're using inheritance for that. I'm trying to think of an interface example that would make sense. Well, to print, to garbage collect it, actually. Used to be used for that. To give all the objects the same like behavior. So I can make them all generic, put them all into an array, and say print. And they're going to all print themselves out. It doesn't really matter what they are. If I run it, I get an error message. No, I get a fraction, and a fraction is 3/10, and that's the print function for a fraction. And then I get a complex number is, and that's the print method for the complex number. So I can get one from each. So. And it's also showing you the is-a relationship. So protocols can be used for tagging or is-a relationships. They can also be used for common functionality, common rules among all of the objects themselves. So. All right, let me go back to this one, inheritance 2. Oops, inheritance 1 is the one I wanted. I was working with the person. So now I'm back at the ranch. I've got the supervisor still. So the supervisor extended employee. If I want to add a protocol to this project, I come up to the top, I go File, New, I go File, and then I make sure I'm in the Coca directory here. And I just say, give me a protocol. Okay, give me this protocol. And then I give it a name. Oh, let's call it printing. I don't know. We already have a printing in the other one. Might as well put a printing in this one. And then save it in here, and lo and behold, I'm back here, and I got the printing protocol. And then I use it just like I used it a few minutes ago in the other one.
Is it like an abstract class?
Nope.
Doesn't have an implementation.
An abstract class in, well, okay, so in C++ abstract doesn't exist. In Objective-C it doesn't exist. In Java, there is a such thing as an abstract class, and it's a class. And one abstract class can extend another abstract class, another, and you're stuck in the one-to-one. If you want to get out of that and you want to use multiple abstracts, you got to turn them into interfaces. Essentially, an abstract class and an interface are the same concept in Java. And we don't have that in Objective-C.
It's synonymous to part of no in Objective-C because you're not implementing the protocol.
If you're not implementing the protocol, you have to.
So we are actually not having a .env for protocols, right?
We can't implement protocols. They're interfaces, or they're protocols. They work like an interface, not as an abstract class. In Java, actually, okay, in Objective-C, you can argue and say in an abstract, if we had abstract classes, they would be the same as protocols. Yes. To answer your question is yes. In concept.
Yes.
In implementation, no abstract. In Java, we have choices. It means the same thing, works the same way, but we have a choice. You don't get a choice. You have to do a protocol. Yeah. Which is an abstract class, if you think about it. Because it's in Java, however, you can have an abstract class that contains partial implementations. So only one of your methods, if you have one abstract method in the entire class turns into an abstract class by rules.
Yes.
Which means you can have just one abstract method, and and everything else is implemented for you. And when you inherit that in, you get all the existing implementation, you just add that one method. In a protocol, you don't have anything implemented. And in an interface, you don't have anything implemented either. You can't put, in a Java interface, you can't partially implement it. If you do, you got to turn it into an abstract class. So, and C++ doesn't have any abstract classes either. You have a virtual. You put virtual in front of it, and it turns into an abstract method. You have a virtual method, by default the class is abstract, but it doesn't really matter because you just go comma, 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 everything in there. So you don't really, it doesn't really make a difference. So, it's actually kind of interesting how all the languages are doing the same thing, they're just doing it differently. So, I don't know, it's kind of interesting. Anyway, I just added this protocol. So I can put the protocol in if I wanted to, use it if I wanted to. I can put it in anything I want in a hierarchy. As soon as I put it in, anything from that level and above uses it because it's inherited. Because everything, so if I have this protocol in, I go back to complex, I make another complex number or another fraction, my special fraction, and then I can still use the printing, with the print, I think it was called print method. I can still use that because it's inherited, because it comes through from any class level. So do we support multiple inheritance? Yeah, kind of, sort of. But it's facilitated through protocols. And then we take the entire concept, and this is just to complete the big summary for you. In Java, we have static. Instead of something being an instance level, it's a class level. What do we have in C++? Is it static as well? I think it's static as well in C++. Same terminology. In Objective-C, we put it in a category. And we make it a plus symbol instead of a minus symbol. And we turn it into a class method. So we have the same thing. We just don't use static, and we don't put it in this. It doesn't belong. And I've never actually figured out why we have that in C++ and Java. Why put something that doesn't belong to the object inside of the object? You put something in there that's a class level that's going to keep track of the IDs or something. Well, why are you implementing it inside of an object when the instance isn't going to use it? You have to access it from the class level in order to use it. Objective-C will just pull it out of the object. Same concept exists. You just take it, you stick it out, and you use the category. Just stick it in there. In fact, you don't even have to inherit or use it. You just add it to the project. If you add it to the project, then you can use it inside just as if it was a class level anything. So we can create class. We're going to do this in the second weekend as well, because I'm looking at the time. It's like 4 o'clock. So I'm not going to go into categories like I did protocols. But I'll do that in the second weekend. I'll repeat protocol with an example with a project. Actually, we'll do protocols and categories on iOS, because that's where it makes more sense, actually. We'll do it on an iPhone or iPad tutorial. But and we'll do more tutorials next time, too, because more people will hopefully have computer equipment with them. But long story short, it never made any sense to me to put it inside of an object. Pull it out of the object, put it in a category, include the category, use the category. Yeah?
Yeah, I think we're talking about class level methods.
Yep. The pluses instead of the minuses.
What if you have to, like in Java, they have static.
Yep.
Making class level, I think, is when you have to share the method within multiple instances of object. Then if you have, just a method, then it's for the instance of that object. You have
That's an instance method. Yeah.
If you have multiple objects, but you have to implement shared method, at that time you are going to class level.
Yep.
Here also the concept.
It's the same concept. It's exactly the same. It's equivalent to static. It does the same thing. The location's different. You can still do it. You can still put it inside of an object. You don't have to separate it out. If you don't separate it out, it's hard to find it. If you separate it out, then you can have a whole repository of these things and just include them in your projects. And then you have all this existing functionality that you have. You can extend existing libraries to add on more string formatting stuff. In fact, that's what we're going to do. We're going to complement the string, and we're going to add some more functionality to it to reverse a string or something like that. I can't remember what the example does. I think it's called reverse string. It's an iOS. It works on an iOS system. But long story short, if it's separate, you can keep those in a separate directory, include them into the project, use them over and over again, easier to find. In Java, you stick it inside, or C++, you stick it inside the project. It's inside of one of the class implementations. And then you use it from outside from a class level instead of from the instance levels. But all instances share the same value. Concept works the same way. It's just physically written inside the object because there's no such thing. In Java, all you got is .java. You got class after class after class, which is what you get in C++ too. You got class, class, class. In Objective-C, you got class. Then you got protocols, you got categories, and actually you've got interfaces. But that's, I don't want to confuse you with that concept either. But long story short, and you have templates. Well, you have templates in C++ too for data structures. And you have packages in Java that you don't have in Objective-C. So, same thing as static, long story short. Same functionality. All right, so I just put a protocol in here. If you look at the menu for file and adding, if you go into the Coca group, you got only two options. You got your categories, you got your protocols. Class extensions is a new object. It's a .h file to add multiple class interfaces into one implementation. We saw this actually with, let's go back, with employee. No, let's go into supervisor now. Let's go into main, where you can add another interface into the class to implement multiple interfaces. You get this a lot more with iOS development because you have an interface that's going to give you particular methods that you want to put into the object that's going to be implemented for specialized behavior. Actually, you get this with Android, with controllers. So you have a list view component, and you're constantly putting in extra interfaces to implement the on-click and the rotate or the select or multiple select or all of the different little options you have. You have the same capability with Objective-C as well to implement multiple interfaces as well as protocols. So usually you get to one-to-one, one interface with one class, but you can double it up in concept or triple it up. So you have multiple interfaces that go into one implementation. Same thing you get in Java for Android. Actually, you get it with a non-Android too, but it's really used a lot in Android development. So let's see what I have not done out of this one here. So anyway, we could go through the supervisor and add some more stuff to it, but you could probably figure out how to do it just by looking at employee. Employee, just add some stuff to it. Add another initializer to it. And I think I already showed you here, if I remember this right, that we made an instance of a supervisor. I didn't implement an init, but this init's coming from an employee probably. Actually, good point. I wonder if what is the initializer doing? Do I have any initializer set? That's a good question. Nope, employees doesn't have an let's see, person has an no, person doesn't have an initializer either. So yeah, this example is not really big on initializers. So, but you'll get some practice creating initializers in your homework or in your assignments. So the biggest part you've seen actually in terms of the basic functionality. So I'm going to stop this one, I believe. I believe I have a third. Nope, I have the protocol in here, which is good. So, all right, I think it's time for another break and another good segment too. So let me stop this. I'll clean up my desktop and find something else for you guys to do for the next little bit.